In this video, we're going to take a look at filling in the unit circle. This includes finding the angles in both degrees and radians and identifying all of the coordinates for each of these angles. The unit circle is a circle of radius 1 consisting of angles and x and y coordinate values. When we first begin filling in our unit circles, we need to identify where our x and y coordinate values are going to be positive and negative throughout the circle. When we first begin, our first values here all are within the first quadrant. We therefore know that the x and y values will both be positive for all of these coordinates. For the second part of our circle, we have entered the second quadrant. We know that our x values will now be negative and our y values will remain positive. When we enter the third quadrant, both x and y are now negative. And finally, the fourth quadrant, x becomes positive once again, and y remains negative. The next thing you want to do is to fill in the basic coordinates that you can identify without knowing any of the angles. Our first coordinate here, our x value is 1, and our y value is 0. Our next coordinate, our y value is 1, and our x value is 0. Our next coordinate, our x value becomes negative 1, our y value is 0. And our last coordinate that we can identify without angles is that our x coordinate is 0 and our y coordinate is negative 1. We can now begin filling in the angles on our unit circle. We start at 0 degrees and we move counterclockwise around the circle, identifying various angles as we progress. Our first angle is 30 degrees with respect to our positive x-axis moving counterclockwise. We then hit 45 degrees. You can see that this makes sense based on the fact that it is about halfway between 0 degrees and the next angle we can identify, 90 degrees. Between the two we have 30, 45, and then 60 degrees. You see 30, 15, 15, 30, and we follow that pattern around the entire circle. So 90 plus 30, 120 degrees, 15, 135 degrees, an additional 15, 150 degrees, an additional 30, 180 degrees. We have a straight line with respect to our positive x-axis. Our next angle, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330, and finally we have completed our circle back at 360 degrees. We now want to fill in each of these angles with their respective value in radians. Radians is simply a conversion between degrees and radians with the knowledge that 360 degrees is equal to 2 pi radians. We start at 0. 180 degrees we know is going to be exactly half of 360, so we know it's pi radians. We can then fill in pi over 2 being half of that, and 3 pi over 2 being 3/4 of our entire circle. And once we complete back around for 360 degrees, we have 2 pi radians. We can now fill in all the values in between. Here we have pi over 2 halfway, pi over 4, halfway between pi over 2 and pi, 3 pi over 4. Halfway between pi and 3 pi over 2, 5 pi over 4. And halfway between 3 pi over 2 and 2 pi radians, 7 pi over 4. We can now fill in all the additional values. Pi over 6 is exactly 30 degrees. Pi over 3 is exactly 60 degrees. We can now continue from there. So if you notice, we have pi over 6. Pi over 3 is equivalent to 2 pi over 6, 3 pi over 6, 4 pi over 6, or 2 pi over 3, 5 pi over 6, 6 pi over 6, or pi, 7 pi over 6, 8 pi over 6, or we can write it as 4 pi over 3, 9 pi over 6, or 3 pi over 2, 10 pi over 6, or 5 pi over 3, 11 pi over 6. We have now filled in all of the angles in both radians and degrees for our unit circle. Now we can begin filling in our coordinates. Now we know that the radius of our circle has to be 1. We find that with our very first coordinate, our y value is going to be 1/2, and our x value is going to be square root of 3 over 2. We now move on to our next coordinate, 45 degrees. Our x value is square root of 2 over 2, and our y value is square root of 2 over 2. And finally, 60 degrees, we fill in. Our x value will be 1/2, and our y value, square root of 3 over 2. If you notice, from 30 degrees to 60 degrees, the only change is that our x and y coordinates switch. We can now fill in this pattern with respect to all other coordinates in our unit circle. Our y value and x value for each of the 45 degree angles will not change numerically. All that will change is their sign. So, 135 degrees, we have the same numerical values, but now our x coordinate is negative. For 225 degrees, we once again have the same values, but now both coordinates are negative. And finally, 315 degrees, same values, and now only our y coordinate is negative. For our other values, as we begin here to pi over 6, we saw us change to square root of 3 over 2, 1/2. As we go here in the same direction, we have our same values, square root of 3 over 2, 1/2 for our y coordinate, except now our x coordinate needs to be negative. Up here, for 120 degrees, we have the same values as 60 degrees over here, 1/2, square root of 3 over 2, and once again, our x value needs to be negative. As we progress to the unit circle, we can now do 210 degrees. You can see it's going to be the same numerical values as 150 degrees. So we have square root of 3 over 2, 1/2, except now both values are negative. And down here, once again, we just do the switch, 1/2, square root of 3 over 2. Both values are negative. Finally, our last quadrant, 300 degrees. We have the exact same angle as we did here. So we have 1/2, square root of 3 over 2. And our y coordinate needs to be negative. And we can say square root of 3 over 2, 1/2. And our y coordinate needs to be negative. All values have been filled in. We now know our x and y coordinates for each of the angles. The last thing to note with respect to sine and cosine values, the sine of any of the angles in our unit circle, so the sine of theta, will be equal to the y value at any of those coordinates, and the cosine value at any of the angles in our unit circle, cosine of theta, is equal to our x value for any of our coordinates in the unit circle. Okay, that concludes our video today on filling in the unit circle.